Okay, so today we're talking about inequalities in one triangle. Okay, what is an inequality? An inequality is, the definition is for any real numbers A and B, A is less than B if and only if there is a positive number C such that A plus C equals B. That's kind of hard. What does that mean? You have these two numbers, one is less than another. Okay, there has to be some third number that you can add to the smaller one to make it equal to the larger one. That's really what an inequality is. Okay, and so some properties of inequality are the comparison property. One number is less than another. One number is equal to another. One number is greater than another. Okay, they all have a relationship somehow. One's less than the other, greater than the other, or equal to each other. The transitive property works for inequalities. Okay, if A is less than B and B is less than C, then A is less than C. And if you think about it, let's say 2 is less than 5 and 5 is less than 8, then 2 is less than 8. That makes sense, right? Okay, so that's the transitive property for inequalities. We also have the addition property of inequalities. Okay, and the addition property allows you to add the same thing to both sides of the inequality, and it doesn't change it. Okay, so if you have A less than B, you can add C to both sides, and it doesn't change the inequality. You can also subtract something from both sides of an inequality. Can you multiply or divide something? You can, right? As if it's positive, nothing's going to change. But what happens if you multiply or divide by a negative here? Remember? The direction of the inequality has to switch. Okay, and we're not really going to get into that, but I just wanted to refresh your memory on that. Okay, so our first theorem that we want to talk about is the exterior angle inequality theorem. Now, if you remember from last chapter, we learned if you have an exterior angle, what is it equal to? The sum of the remote interior angles. So the measure of angle 1 is equal to the measure of angle A plus the measure of angle B, right? That's what we learned in the last chapter. This theorem says that the measure of the exterior angle is greater than the measure of either of its corresponding remote interior angles, which makes sense because if this is equal to the sum of those two, A and B, then angle 1 is going to be greater than A and it's going to be greater than B, right? So that's what that theorem tells us. So the measure of angle 1 is greater than the measure of angle A, and the measure of angle 1 is greater than the measure of angle B. Because it's equal to their sum, it's greater than either one of them separately. Okay, so we're going to use that idea, and we're going to look at some figures, and we're going to determine which angles are greater or less than others. It says use the exterior angle inequality theorem to list all the angles that satisfy the stated conditions. Now, one thing though that I want to caution you about is you can't just say one thing is greater than another because it looks like it. Okay? Do not go by how large the angle looks. Okay, do not go by how large the angle looks. You can't just, okay, for example, they want you to use the exterior angle inequality theorem to make this determination. The first one wants measures less than angle 7. Well, here's angle 7 down here. Okay? You can't just look and find one that looks to be smaller than it. Okay? There has to be a reason for it to be smaller than it. Because sometimes angles could be greater or less than just depending upon how the triangle is drawn. But if we use the triangle inequality theorem, it will always follow that procedure. Okay, so we want measures less than angle 7. So what we want to do is we want to look at the triangle that angle 7 is a part of. And it is a part of, first of all, this triangle right here. So if I looked at that triangle, angle 7 is going to be, or which angles are going to be less than angle 7? Okay, angle 4 and angle 5, right? So angle 4 and angle 5. Now, I'm not going to list angle 6 because it just is a linear pair with it. Depending upon how the triangle's drawn, it could be less than or greater than it. It just happens to be less than it because of the way it's drawn in this picture, but I would not list that. But no matter how the triangle is drawn, angle 4 and 5 will always be less than 7 because they're remote interior angles and 7 is an exterior angle, right? Okay, is angle 7 an exterior angle to another triangle? The bigger one, right? If I look at this bigger one right here, okay, what other angles are less than angle 7? Angle 1 and what? Angle 1 and angle 2. And angle 2 and 4 together, actually, right? Because this is actually the remote interior angle, okay? So you would list angle JKL. You would list angle JKL, but you would also list angle 2 because angle 2 is part of angle JKL. Okay? So in this case, angle 7 is greater than all of those angles. Any questions on what I did there? Okay. Let's look at the next one. It says measures greater than angle 6. Measures greater than angle 6. Yes. I did have it. Yeah, I got 4. Yeah. Okay. Measures greater than angle 6. What do you think? Anything greater than angle 6? I would look at the triangle that angle 6 is a part of, right? Is there an exterior angle there? 3, right? I can extend this side, and so is 3 going to be greater than 6? Yes, so that would be one of them. Okay, would I list 7? No, because it's just a linear pair, right? So it asks me to use the exterior angle inequality theorem. Okay, so is there another triangle that 6 is a part of? This bigger one, huh? Isn't it part of this bigger one as well? So if it's part of that bigger one, is there an angle greater than 6? Huh? Is there an exterior angle that's part of that 8, right? 8 is an exterior angle, 6 is its remote interior angle. So angle 8 is going to be greater than angle 6 also, okay? Alright, I think that's it because I don't think there's any other exterior angles that we could utilize. Any questions on what I did there? Okay, remember, your exterior angle is greater than either of your remote interior angles. Okay. Alright, now, I'm going to come back to these two triangles here in just a second, okay? Now, my next theorem says that if one side of a triangle is longer than the other side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Kind of wordy, but what it means is if one side is greater than the other, then the angle across from that bigger side is going to be bigger than the angle across from the smaller side. So, if xy is greater than yz, so this 9 is greater than the 7, then the angle across from the 9 is going to be greater than the angle across from the 7. So the measure of angle C is going to be greater than the measure of angle X. So you can just, and this only applies within a single triangle, okay? So if you can look at two pairs of sides, and if one side's bigger than the other, then the angle across from the bigger side is going to be bigger than the angle across from the smaller side. Now let's look at this next theorem. It says if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. So it works with angles as well. Within this triangle, I can see that angle J is greater than angle K, right? So if that's the case, then the side across from angle J is going to be greater than the side across from angle K. So if the measure of angle J is greater than the measure of angle K, then the side opposite J, which is KL, is greater than the side opposite K, which is JL. So what that boils down to, go back up here to my triangles, that the longest side is always opposite the largest angle. And the smallest side is always across from the smallest angle. Actually, the shortest side. So the shortest side is across from the smallest angle. But again, you cannot compare two different triangles. This is only true within a single triangle. Okay? Within a single triangle. And we'll see what we're talking about here in just a second. Alright. So, let's list the angles of triangle ABC in order from smallest to largest. Okay, I want to go to angles from smallest to largest. Now, in your homework, make sure that you follow the directions that it asks you to do. Okay, if it's largest to smallest, your largest to smallest. Okay. All right. So, what would be my smallest? Okay, angle C is going to be the smallest. Okay. Then what? Then angle B, and then angle A. Good. Okay. Let's go the opposite direction. We want to list the sides of triangle ABC in order from shortest to longest. Now, do I have enough information right now? Now, what do I need to do? Add these two together and subtract 180. So if I add those together, I get 106. Is that right? No, 101. 101, which is 79, right? So that's 79. All right. So if I want to go from shortest to longest, what's going to be my shortest side? C is my shortest side. Okay. Then what? And then AB. And then AC. Good. Okay. Now, I want to give you a second to look at this one. Okay. It's a little bit tricky. So think about it. You want to name the longest side in the figure. And remember, the rules that we learned only apply within a single triangle. You can't compare an angle in one triangle with an angle in a different triangle. Okay? Keep that in mind. Okay, so what do you think is the longest side? PR? How many people think PR? Okay. Anybody think something different? Nobody? Don't be bashful. PR is not the right answer. Huh? RS? Yes, RS is the correct answer. Okay? And let's talk about that. If we look at this triangle right here, okay, what's the longest side? PR, right? That's the longest side, correct? If I look at this triangle, what's the longest side? RS, right? PR is a part of this red triangle. Huh? And so SR or RS is bigger than PR. Remember I told you that the rule only applied within the triangle. Yes? Just because this is the longest side across the biggest angle, it's only the longest side of that triangle. Okay? SR or RS is the longest side of that. And PR is a part of that triangle, so SR is bigger than PR. Okay? So, RS or SR is the right answer. But let's kind of explain that because you'll see that again. Make sure that you have something to go back and reference. Okay? Let's go ahead and put PR is the longest side of triangle PQR. RS is the longest side of triangle PRS. PR is part of triangle PRS. Therefore, RS is greater than PR. Yes.
So how do you just like how do you say that RS is bigger than PR? Like
Look, okay, how do you know that? Well, you remember back up here that your longest side is across from the largest angle within a single triangle.
so in this triangle, this is like 65.
Yes, within this triangle, your PR is across from the 65, right? And so it's smaller than this because this is across from the 70. So within the red triangle, your longest side is RS, right? In the blue triangle, your longest side is PR. Even though PR is across from an 85-degree angle in the blue triangle, it's across from a 65-degree angle in the red triangle, okay? And RS in the red triangle is bigger than that. Does that make sense? Okay? All right, so we learned about what an inequality was. We already knew what an inequality was, and some of their properties. Now, in your homework, look in your book real quick. I want to show you something. What page are we on? 348, 349. Okay. When you go to do problems like 30 through 33, the directions say use the figure at the right to determine the relationship between the measure of the given angles. They're wanting you to use this comparison property. You're going to put that one triangle is less than the other, it's equal to the other, or it's greater than the other. Okay? So that's what you're going to do there. You're going to use that comparison property. Then we learned about the exterior angle inequality theorem. And since this angle is equal to the sum of the remote interior angles, this theorem says that this angle is greater than either one of them separately. Okay? And then we learned that within a single triangle, your longest side is across from the largest angle, and your shortest side is across from the smallest. Okay? Basically, in a nutshell, that's what I learned. Okay? All right. Your assignment's on page 348.